So 1B on page 4 really is a good one to practice your algebra skills. So here was the original question. We want to rationalize the numerator. We've got what's called a complex fraction. A complex fraction has fractions inside of fractions. And our goal is to get our final answer to look like this. And the reason this is a good question to go over is we have a couple of different strategies on how we can start this question. And we're going to have to, after looking at this, decide, which of those strategies do I like the best? Which one might I have tried? Or which one did I try? And how can I get to this goal? Because that actually looks like a pretty simplified answer as far as the goal goes. So I'm going to run through this. I'll put this example up on YouTube, so if you want to see the three afterwards, you can. It'll probably be too quick if you were trying to write down all three of them. So if you wanted to write it down, you could go look at it later. But my first time through is I said, I want to simplify my complex fraction. I'll simplify the complex fraction first and just get a single fraction, then see if I still need to rationalize the numerator or not. So it gets back to something you did a fair bit in trig identities. When you have a fraction over a fraction, one of the main strategies is, can I get a single fraction on the top in my numerator and a single fraction in my denominator, and then when I have a fraction divided by a fraction, I multiply by the reciprocal and then can simplify from there. So that's my goal here. I'm going to simplify that complex fraction. I get in here in step 2 a common denominator on the top, so I can put that together right here as a single fraction. And the bottom x minus 1 over 1 is already a single fraction, so now I can multiply by the reciprocal. Once I do that, I end up with a single fraction. Now, you're going to notice right here, I'm not going to multiply out the bottom. Notice right here, I kept it factored. We'll often do that in a question. We'll keep things factored because if there's a possibility to simplify it, it'll make our lives easier. And sometimes when we multiply things out, it's not so easy to factor again. As we saw in yesterday's questions when we went back, oh, we shouldn't have factored this one because we could have simplified something. So now I still have a square root here in my numerator, so I'm going to multiply by the conjugate 1 plus the square root of x to get rid of that, because multiplying by the conjugate will get rid of our square roots. And we end up with this expression. This expression has rationalized the numerator. According to the question, we're done. But we haven't reached the goal, which is the same algebraic format that they had at the answer key. So we have to think, how can I simplify this? And this is an important note off to the side here, that anytime you have 1 minus x, it's equal to negative x minus 1. So in this question, I'll underline it here in green. I see that I have a 1 minus x and an x minus 1. So when you have the same binomial, but they sort of switched with the subtraction, if you factor out a negative, they're actually the same with a negative sign out in front, which then would allow me to factor it. And once that is simplified, because those x minus 1 factors are the same, we get negative 1 on top, and if you multiply the root x through, you get x plus root x, which matches our answer key. So there's strategy number 1. I wanted to simplify my complex fraction first. Strategy number 2. Let's say you decide, I want to rationalize, and so I'm going to start by using the process of rationalizing. I have my 1 over root x minus 1 in my numerator, so I'm going to multiply by the conjugate 1 over root x plus 1. Well, on the top, these two get multiplied together. If that's squared, you get 1 over x minus 1, just like you would with the difference of squares. And on the bottom, I'm not going to multiply it through. I'm just going to leave it factored. Well, I have technically rationalized my numerator, but I have a complex fraction, and now I want to see if I can get it to match the answer at the back of the book. So now can I take this complex fraction, which seems even more complex, than the one we had to begin with, and simplify it to see if I can get it the same. So again, I get one fraction on the top. 1 is x over x. So then I can have 1 minus x over x as my fraction on the top. And on the bottom, I wanted to get a single fraction as well. So I took the second set of brackets, and this one I made root x over x to get a common denominator, giving me 1 plus root x over x. And that's going to get multiplied by the x minus 1 over 1. And so here on the bottom, I have a single fraction. I can now multiply by the reciprocal. So here, I flip this one. I'm going to get root x over x minus 1, 1 plus x. And again, we have to use that special note, that if I factor out the negative, then these ones are going to cancel out. And now I'm left with a root x on top again. So by trying to rationalize early, when I simplified my fraction, I still got a square root in my numerator. So I'm going to have to rationalize again. And just a reminder, when you just have a single square root, you don't have to multiply by a conjugate because it's not a binomial. You're just going to have to multiply by root x and root x. That gives me a single x on the top. I had another single x on the bottom. Those will simplify. And when you multiply that root x through, sure enough, it matches up again. Of the two so far, it seemed like simplifying our complex fraction first was a little bit less work, because rationalizing first gave us more complicated fractions. So I'm going to show you, this is what we did for simplifying the complex fraction in A, where we got a single fraction over a single fraction, is what you did most often in trig identities, and it's a very, very good strategy. It's probably the one you go to more often. I'm going to show you another technique for simplifying a complex fraction that you may want to use at some time. So this is similar to this one. This is simplifying complex fraction. I have part B. Well, if I would like to get rid of that square root of x on the bottom, what I need to do is multiply by a square root of x. Now, anytime you're simplifying a fraction, you can always multiply by 1, because multiplying by 1 doesn't change what it's equal to. Now, what that 1 looks like, you get to choose. In this case, I chose square root of x over square root of x. The reason I did that is, can you see when I hit this, multiply that square root of x times that, they're going to cancel out. And in fact, it's just going to give me, I multiply it by that one, 1 minus the square root of x. So I get rid of my complex fraction early. When I multiply the bottom through, I'm just going to get square root of x times x minus 1. And again, I didn't multiply that out because I want to keep things factored so that maybe later on I can simplify. That got me to this step really quickly. If we look back in our first example, how long did it take us to get there? It took us 2 steps. So maybe this is a slightly faster technique. And then everywhere from now on will be exactly the same as we had before. We multiply by the conjugate. We have to use our special note and factor out the negative so that things simplify. And then when we multiply it through, we get our answer. So 3 different algebraic techniques, and this is the thing that I really want you guys to practice this year. It's not about getting a question done quickly. It's about exploring the different ways that you can come to that answer at the end, because that's where you're going to really build your skills, and those skills are going to be super helpful when you get to university.